For lesson 2's homework, we're going to work on graphing linear functions. So the first one says two lines, y equals ax plus b and y equals cx plus d, are shown and graphed below. The values a, b, c, and d are not given, but properties can be inferred about them. And when we say inferred, we're talking about can be estimated. Circle the pair of values that could be equal and explain your answer. So I'm going to look first at y equals ax plus b. So as I look at that, I see my y-intercept and I see my slope. So the way I look at that is a must be a positive number because my slope is positive, and b must be a positive number because my y-intercept is clearly above the x-axis. Then I'm going to look at y equals cx plus d. So my slope here is clearly a negative slope. And d, well, that's still positive though, because that's a positive y-intercept. So I don't know any of the values of these numbers. I just know that a, b, and d must be positive and c is negative. So as I look at my answer choices, b and d. Now b and d are both positive. Those are my two y-intercepts. But as you can see, those are very clearly two different points. So since they intersect at different spots and they're both the y-intercepts, they clearly are not the same numbers. If we look at a, which is a positive number, positive slope, not sure what it is, and d, positive y-intercept, but not sure what it is, well, that seems to me like they have the ability to be equal. And actually, I'm going to change the colors up on that one. And then the last one is a and c. Well, a is positive and c is negative, so clearly those are not the same. So the only one that has the option is a and d. Both are positive numbers. And that's really the only thing we can infer about each of them, so therefore those are the only two that might be the same. If we look at our next one, we want to graph it. Now this one's pretty easy because it's already in y equals form. You could plug it into your calculator and make a table, but I look at it as I have a y-intercept of 2 and I have a slope of negative 2 over 3, which is down 2 and to the right 3. When we're analyzing our slope, we always are going to apply that negative to the top number, and then that'll tell us to go up or down, but the bottom number is always going to be to the right. So I'll start on my y-intercept of 2. I'll go down 2, right 3, down 2, right 3, down 2, right 3 until I run out of space. Once I do that, then I'm going to go in reverse. The reverse is up 2, left 3, up 2, left 3, up 2, left 3. And then I will be able to have my line that connects all of those points. So there's my line, y equals negative 2/3 x plus 2. In the next one, we have to do a little bit of work first because it's not in y equals mx plus b form. So I'm going to bring it over to the side here. Now, this one's a fairly simple version because we just have to get the y by itself. So we're going to divide everything by 5, so that y is by itself. 10x divided by 5 is positive 2x, and negative 5 divided by 5 is negative 1. So now I have a y-intercept of negative 1, and I have a slope of 2, and we're going to put it over 1 just so that we can make everything nice and easy, which really means we have a slope of up 2 and to the right 1. So my first point will go at negative 1. I'll go up 2 over 1, up 2 over 1, and I'll follow that same pattern the whole way. Then I'll go in reverse, down 2, left 1, down 2, left 1, and so on until I have run out of space. I'll connect all those points with a line, and then I am at my final piece of y equals 2x minus 1. Now, if you're in the habit of labeling all your equations, we don't have to now because there's only one on each graph, you can label it with either the original one or the one that you rearranged and solved for. So now this one involves a little bit more work than the previous one. Obviously, it is not in y equals form, but now this is going to be a two-step rearrange. So I always like to try to leave my y on the left-hand side. So I'm going to subtract 6x and subtract 6x from both sides. I have to make sure I bring down the negative 4y. I also always like to put my x term first, so that this way it stays in y equals mx plus b. I'm now going to divide everything by negative 4. Y equals, the two negatives here cancel out. 6 over 4 is going to simplify to 3 over 2x, and then 20 divided by negative 4 is negative 5. So I have a y-intercept of negative 5 and a slope of positive 3 over 2, because again my two negatives canceled out. So I'm going to be up 3 and right 2. So 1, 2, 3, 4, 5. There's my y-intercept. And then we're going to be up 1, 2, 3 over 2, up 1, 2, 3 over 2, so on and so forth. We'll follow that same pattern, and then we'll go in reverse. Down 3, left 2, and that's only 1 point that's going to fit there. We'll make a nice line here, connecting all of our points, and then that was going to be our graphed line. For our final equation, we want to use which of the following represents the average rate of change. So when you see that, you should be thinking y2 minus y1 over x2 minus x1. For the linear function g of x equals 3 over 2x plus 1. Now you could absolutely go ahead and find your point at negative 2 and find your point at 8. That would be your x1 and your y1, your x2 and your y2. However, average rate of change is equal to the slope of a linear function. So because they gave us the equation, we know right off the bat what our average rate of change is. There's our slope of 3 over 2. So there's our average rate of change of 3 over 2. And again, if you went and found out what those points were to plug in for x1, y1, x2, y2, you would end up with the same exact answer of positive 3 over 2 that you would get with your slope. But if you remember that average rate of change and slope are equal, there's actually no additional work to do for this problem.